Hi, welcome to this new video. In this video I have opened two PyCharm projects. This is a previous app that we built, the Instant Dictionary web app, and this is a new project that I've just created, and in this new project I'm going to build the API. I'm keeping the dictionary object open here because we are going to use this definition class that we have in our definition.py file. We are going to need that for our API. So we are making a REST API which works based on web requests. So a client, the app, is going to make URL requests. The API is going to process this URL request. It's going to see what is inside the URL. Maybe there is a word, like for example a rain in the URL, part of the URL, and the API is going to read that word and is going to ask the definition class for the definition, and then it's going to send back the response in JSON format to the client, for example to the mobile app. Therefore, we kind of need a web framework here for Python to be able to handle these web requests. And you can do that with Flask. You can also do that with JustPy. We are going to use JustPy. Both Flask and JustPy are very easy to build an API. So let's open the project directory. So Instant Dictionary API. That's how I named this project. Before I create any file, I want to enable version control from VCS, enable version control integration, and press OK for Git. And then I'm going to create an empty Python file where I'm going to write the API. One file should be enough. So API, add it to Git, and I said that we're going to use JustPy, so let me import JustPy. I haven't installed it, so I'm going to install JustPy. Then, as a package installs, I'm going to create a class, and I'll name it API with a method serve. So the class is going to have the same structure as a page class, as you see here, but it's not a page. And you know that with JustPy we work with classes as opposed to working with class instances, and therefore we need this class methods here. So we discussed that, why we need a class method, in the previous part of the course where we build the Instant Dictionary web app. This would have a CLS and rec as parameters. So we're doing basically the same thing. A web page would be enough here, so not Quasar page. We're not building a fancy web page in this case. It's going to be a web page which simply returns some JSON data. So what this serve method will do is it's going to handle URL requests. And we expect from the client that in those URL requests, the client should enter a URL parameter, which contains the words. For example, the client wants to know the definition for moon, and moon is going to be contained in the URL. So we are going to use a query params.get. So this attribute of the request object, this one in here, this request object, which has this attribute and it has that get method, this has that get method, and here I'm going to enter W. You are going to understand what this is all about in just a bit. But basically what this is doing is it's getting that value, that word from the URL, and we want to store it in a variable, word. And then return WP, so the web page, because the request handler should return a web page, a JustPy web page. Now the web page at this moment it has nothing, but we could add something there, such as a div with text equal to, let's say, word.title. So the word that is going to be passed to the URL, but with the first letter capitalized. And let's add this to WP, and then we return WP here, so the web page. Then we do the root class, we initialize it, so when the user visits this particular path, which could also be API it doesn't matter as far as you document it well in the API documentation, where you specify how an API can be used. So you specify the specific URL that the client has to send requests to, so that they can get the data. So we decided to have the requests in the home page, and then we have the request handler, which is api.serve without the parentheses, and then we start the server using the justby function, and then we run it. We visit that web page. Now, why did we get an error? We get an error because a request to the API was not made as it was supposed to be. The correct request would be this: $w equal to moon. And then we get moon here with M capitalized. So that is how the requests are made to our API. Now that could be another URL, such as that. So rerun, reload. In that case, we would have to enter here, after the slash, we would do API, and then the question mark, and then W equal to moon. And we get the same exact output. So I can copy that URL and just use it as a doc string here, so that I know what is the format of the requests. Handles requests at, and I can say word here to be more general, just like that. So what's happening here is that when the server starts and the user visits this particular URL, this method is executed. And what this method does is that it creates a web page, but then it tries to access this object, which is an attribute of that request object. And then we try to call the get method of that particular object. And this get method tries to get the value of the W parameter. So this here is a URL parameter. So that's a standard format of making requests, URL requests with parameters. Therefore, this will return the value of that parameter, which in this case is moon. So moon is going to be stored in Word. And then we just make a div, a simple div. And in that div, we write the title version of that word that the user entered in the URL request. Now this works, but it has a problem. If you look at the source code of this, you're going to see that this page has a lot of HTML code and JavaScript code, which is very, very unnecessary, and we want to serve clean data to that client, not all these unnecessary data. And we are getting this because we are using a division, so a full HTML page. So how can we serve only the text so that it is readable by a machine, by a mobile app, for example, instead of being readable by humans? So in the next video, I'm going to show you how you can return only the text, so the moon as text only. See you in the next lecture. Hi and welcome back. In this video you are going to learn how to return JSON data as a response instead of returning a full HTML page which has unnecessary HTML and JavaScript code, which would be a mess to be readable by a machine. But this is very easy to do, actually. So we shouldn't use divs or components, HTML components. What we should do is we should access the HTML property of the WP variable of the web page instance and set a value for that. In this case, it could be word, the value. So word is just a Python string, just text, plain text. Therefore, what we're doing is that we're setting the content of WP to that value. let's see how that is going to change the output. Reload. So we got moon. It's not capitalized because I didn't apply .title this time, but you can do it. And you're going to get the text again capitalized. Now, if I right click and I go to show source page, what I'm going to see this time is just text, just moon. You don't see anything else. That means this page now is readable by a machine. Now that this is readable by machines, instead of returning the text that the user basically passed in the request, so moon here, moon there, instead of doing that, let's return the definition of moon. To do that, we need the help of the definition class. So what I'm going to do is, in my API project, I'm going to copy the definition.py file and paste it in here. Add it to Git, and pandas needs to be installed because definition uses pandas. So API and definition.py are in the same directory. Therefore, I can go to API and import definition. Then we want to use this definition class. And we know how to use it from here. So instead of writing it all over again, I'm just going to paste that here. So defined, the value is going to be word. That one. And get is going to give us the definition. And then defined should go in here. And it's as easy as that. Rerun the app. We get this error. That means we haven't placed the data.csv file in our project. So let's do that. Just copy data.csv from your previous project into the project directory here. Press OK. And add it to Git. Close the file. We don't need to see it. And that should fix the issue. So reload. And yeah, this is what we get. We get the definitions of moon. And if you see the source code of this page, you're going to see that it's plain text again. So it's easily parsable by a machine. However, this is not perfect yet because this is a tuple and this is not a standard format of communicating data between applications. We should use JSON. So JSON is one of the standard formats that you should use with REST APIs. And this is what we're going to do. So let's slightly change this code in the next video by making it serve JSON data. I'll talk to you in the next video. Hi, welcome back. Our API is able to handle a request now, so any word that you enter here as a value of the W parameter, you get the definition of that word, and it's pretty quick. Now we want to change this format to a more standard format, such as JSON. Let's do that. To be able to do that, we need the JSON library, which is a standard Python library. And then, usually what you do with REST APIs which return JSON response is you create a dictionary. Let's name this response. So you want to construct a dictionary, how you want the response to look like. And then you have to document this response in your API documentation so that others who use your API know how to get the data of your API. So in your API documentation, you want to document both how the requests, the URL requests can be made, and also how the response is structured. In our case, the response could be structured like this. Let's say word. So a key and a value, a comma, again a key and a value, definition defined. And then here what we want to do is we want to say json.dumps, and this gets a dictionary as input. In this case it would be the response dictionary. And this method, what it does is it produces a string out of a dictionary. I can demonstrate it to you. So import json.dumps. Let's say this is a dictionary, A1, and you get a string. So you get the dictionary, but enclosed in quotes. So it's a plain string. And we need to convert it to a string because the HTML property expects a string as a value. So let's make a request again, API, just like we used to do, moon. And in this case, you are going to see that we get JSON as a response, which is a standard response that can be read by machines, by applications. And that completes our API functionality. Now, an API would not be complete if you didn't write any documentation about your API. So let's write some documentation in the next video. See you. Hi, welcome back. Previously we built the API, so the functionality is working now. The API is able to handle requests and return a response. In this lecture I'm going to create a simple documentation for the API. Although that might be obvious, but I want to keep this API complete, so I want to emphasize that the documentation of the API is also important. So in this root directory I'm going to create a new Python file and say documentation. So documentation.py. Basically what we want to do here is, for example, if you go to the newsapi.org, what we're looking at is an API. So this is the documentation of the API, and the documentation specifies how you can use the API. So basically we want to do the same thing. We want to have in the home page, we want to have the documentation. In our case, one example would be enough. So we could just say that you could get definitions using this example URL request. And then we can mention the response further down. So let's do that. I'm going to get a page from our previous app, such as the About page. So copy that and paste it here instead of writing it all over again. So let me maximize my API project, and I'm not going to inherit from the page abstract class, and I'm not going to use a layout because it's just some simple documentation. So I'm going to delete layout and the page container and use a web page. Delete that because when you use a web page class, Tailwind is true by default. So the main div would belong to WP. And then here we could set the title of the documentation page. Like that, for example. And then another div. So as text, we could say get definitions of words. And then we could use an HR component, which would create an horizontal line. That is part of div as well. Then another div belongs to the main div with text. Example.com. Of course, here you'd have to change that to your URL where you deploy your app, because you basically normally you're going to have a domain on the server where you deploy your app. But then the next part is important. So in our case, it'd be API question mark W is the name of the parameter, and an example you can use, for example, moon, and then again maybe a horizontal line, then another div with text. So let's have it a string that supports multiple lines, and here between I'm going to paste this request that the user expects as a response. This response which belongs to that particular request. So let's try to format it better. Alright, that should do it. And then we want to serve this page. How do we do it? Well, our justPy function is in the api.py page. So we want to add here a root. But even better would be, since we have multiple files now, then we want to have a better structure. So in this case, we want a main.py file. And then here we import API and we import documentation, and then whatever we have here we move it here, and then this would be API.API. The home page would belong to documentation.about. Well, no, let's say doc. So let's change that to doc. And we can just remove this. We don't really need it. It's a small application. And also we need to point to serve, the method of that class. And then lastly, we need to import justPy SJP, and we should be ready to go now. I'm going to run now main.py. First, you want to make sure you stop this API process first, because the port is used by API. So close that and run main. And this is our documentation. Of course, it's not fancy, but it sends the message to the users. And that completes the building of our API. So that client, that mobile app built in Java, can now make queries to our URLs using Java language, and they can get the data. Now we are going to behave like a client in the next lecture and use the API that we just built. So let's do that in the next lecture. Hi and welcome back. In this video I'm going to use this API as a client. So my app, it will be a client of this API, the API that we built previously. Before we do that, I would like to repeat the definition of the API again. So I mentioned the definition in the first video of this series. Now I want to repeat it again so that it makes more sense now that you saw what an API looks like. So an API is an intermediary between two applications. In this case, the two applications are the application that returns definitions of words and the application that displays these definitions on the web, which in this case is the Instant Dictionary web app. Now currently this application, if we go to dictionary.py, this page is responsible for the dictionary page, so we can go and visit it just to refresh our memories. So /dictionary, this is currently using the definition class directly, but we can change that, and it's usually a good idea not to use it directly. So instead of that, what we want to do is we want to make a request to the URL of the API. To do that in Python, we need to use the request library, which needs to be installed. And then we make a request using request.get. And here we will be using an f string. And let's see the documentation of the API, what it says. So that's basically the URL. And currently we are running the API locally, so we want this URL, the domain part, we want it to reflect the actual current URL, which is http:// and the rest is, so you can also copy that to avoid typos, and then paste it in here. So http:// the IP, or you can also write localhost here. It would be the same thing. And then a colon, the port /API $w. This would be a placeholder, which is equal to widget.value. So the value that the user enters in the form. And so that would be a request object. Out of that, we want to extract the data out of request using JSON. The JSON method would give us the data in a dictionary format, in a Python dictionary. So that dictionary would have two keys, the word key and the definition key. We saw that in here. So this word key and this definition key. And we are particularly interested about the value of the definition key. Therefore, we want to access from data, we want to access the value of definition, which is a list. It's a list, you see, it's a list of strings. So what we do then is we join those strings. So that would be a list, and we apply join to this white space, and we join all those strings in one single string. And then we set that string as a value of the output div. Now if I rerun this and go to that URL, go to dictionary, write rain here, we should be able to see the data, the output in this box. If that doesn't happen, and it's usually the case when you're just starting out, you can make typos and you don't see errors. You don't see the output, but you don't see the errors. So you want to investigate using a debugger. In that case, I want to set a breakpoint here, run in debug mode, try to type in something here. The debugger will stop, and you see that now we can try this request using evaluate expression, evaluate, and this is the result. And so that's the request. If we apply .json, hopefully to get the dictionary, yes, we get the dictionary. So everything is fine up to here. Obviously, up to this point, we are able to get the dictionary out of JSON. But then I try to access this, and this contains a typo. Definition. So that should be the culprit here. So let me stop the debugger. It was good that this malfunction happened, because now you know how to troubleshoot such errors, so you don't get an error actually, but the application will not work. So now I'm going to run it again. Rain, and this time we get the output. So what's happening is that the application is making a request to the API. Now the API should be up and running for this to work. You can see that my other PyCharm project, so the API project, is up and running here. So you see just by ready to go on this URL. Otherwise things would not work. So I hope that is a bit clear. I hope you understand APIs now and you're able to make a simple API at least. So thanks again, and I'll talk to you in the next videos. See you. Hi and welcome to this new app of the course. Actually, this is the last app and it is a project, so you are supposed to solve this project. You are supposed to build this app on your own. And in this video, I want to explain you what you are supposed to build. And this app is called Cinema Ticket Booking. I have built this app already and it consists of these files. So we have two DB files, database files, where the data are stored, and we have this main.py file. So I'm not going to show you the code right now, but basically all the code of the app is inside this main.py. Feel free to have multiple files if you like to split the classes into multiple files. I didn't do that, I didn't find it necessary, but it's up to you. It's perfectly fine if you split it. And this design.txt is just some notes about the design, so it's not related directly to the project. It's not an integral part of the project. And these two files, I'm handing them to you so you can find them as resources for this project. So you're not supposed to build these two files from scratch. The app is supposed to find them ready from some other instances. So let me show you what these two databases contain. You can view the data of these databases using the DB browser program. So that program we installed and we used it, you learned how to use it in the previous section of the course. So let me now show you what these data look like. So go to DB browser on your computer and then go to Open Database to browse the database that I'm providing you for this project. So let's first look at cinema.db. So it has one table, the table name is sit, and if we go to browse data, we're going to see the data for the table seat. And you see that we have like 6 rows here in the table. We have a seat ID column, a taken column, and a price column. So every record, every row symbolizes one seat of the cinema. And so we have different IDs for different seats. Every seat has an ID. And then we have a taken column, which means that if the seat is taken or not, for example, A1 is taken because it has 1 as value. So a value of 1 means that the seat is taken. A value of 0 means the seat is free. So it's free to be taken by a user, by a client, by a customer, wherever you call them. And every seat has a price, so there might be different prices for different seats because, you know, in a cinema some seats are more preferable, so it makes sense to have them more pricey. And that's all about the cinema.db database. Let's open the other database, banking.db. So go to database structure and you'll see that this database has one table, it's called card, and you go to browse data and you see the data for card. So card, that table has 1, 2, 3, 4, 5 columns. So the type column having either MasterCard or Visa, so the type of the debit or credit card. And then we have the number of the card. I just entered some fake numbers, of course. So 2, 3, 4, 5, 6, 7, 8, 9 for this first record, and 1, 2, 3, 4, 5, 6, 7, 8 for the other record. And the CVC, this is a number that debit or credit cards have, usually on the back, so it's like a security number. And each card has the name of the holder, the person who owns the card. So Mary Smith in this case, and the balance, the current balance of the card. So 2000 for that first card, and 460 for the second card. So we have just 2 examples of cards here. And that's about the databases that we have for this project. Now let me show you how this app works, so how the end product should work, so you can try to build the same behavior more or less. If I run now main.py, so this file, that one in there, so let me right click it and run. The app is supposed to ask us for our name, so let's say John Smith, preferred seat number. So as you can see, I didn't build a graphical user interface for this app. I just chose to go with a simple command line interface. But feel free to make your own interface if you like. I wanted to focus on the core of this program, so on building the classes and the interaction between classes. The other part, whether you want to build a Kivy interface using the Kivy library or JustPy to build a web app interface, that's up to you. So in this case now, preferred seat number. If this was a web app, the user would maybe select a seat graphically. You know, you'd show probably a grid with seats graphically, where these free seats are in green color and occupied seats are in red and so on. And then the user would select a green seat. So let's say they would select seat A2, which is green, and that means the user is giving the program some input. The input is A2 or A1, whatever seat ID that is. And so that's the idea here, that we are pretending we are getting some input from the interface. So the user here would say, for example, A2. So A2 is free, so yes, A2, then press enter. The program keeps asking for input, your card type, Visa, your card number. So Visa was 1, 2, 3, 4, 5, 6, 7, 8. That was the card number for Visa in the database. So banking.db, Visa 1, 2, 3, 4, 5, 6, 7, 8. And enter. The CVC was 1, 2, 3. Yes, 1, 2, 3. Press enter. Cardholder name was John Smith. So I know that we asked for the name already here, but sometimes people use cards from different persons, so it makes sense to ask for the holder name here. John Smith. So John Smith. Enter. Purchase successful. So the program returned purchase successful. And it generated this sample.pdf file, which is a PDF file. And here we have the digital ticket of the user. So the name, John Smith, and ticket ID. This is just a random string that the program is generated for every ticket. The price 100, so that was the price of the seat, and the seat number was A2. So that's one functionality of the program, generating a PDF ticket. But also you'll see that now the balance of this card has been decreased. So it was 460 the balance. Now if I refresh this table to reflect the changes that the Python app did, we are going to see that this gets lowered to 360. So 460 minus the price of the seats, and we get 360. Right, if we open the cinema.db database, we are going to see that A2 now is taken. So the value for taken for A2 is 1. Now, that means if we run the program again, and Mary tries to get seat A2, which is already occupied, and she has a MasterCard with a number of 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, The card CVC is 234. Card holder name is Mary Smith, yes. And we get this seat is taken. So before with John we got purchase was successful or something like that. Now we get seat is taken, and you see that if we refresh this table, no money has been taken out of the balance of this card of Mary. So this was the second scenario. So the first scenario was when the purchase is successful and the money is taken from the balance. The second scenario is when the seat is taken, and there is also another scenario when, let's say, John Smith, he wants A3 now, which is not taken. We can see A3 in cinema.db is not taken. The seat is free. And John has a Visa card with number 1, 2, 3, 4, 5, 6, 7, 8. So that's a correct card number. But now we're going to just set a fake number, a wrong number for this card. So instead of 1, 2, 3, which would be the correct CVC, so the security number, we would say 0, 1, 2. And finally, card holder name, John Smith. So execute. And this time we got this message. There was a problem with your card. So this is the third scenario that your app should take into account. So the first scenario is when the purchase is complete. The second scenario is when the seat is taken. And the third scenario is when the card details are not correct and the program doesn't finalize the purchase again and displays the message there was a problem with your card. So that's what your program should do. I hope it was clear and good luck with it, and I'll talk to you in the next videos showing you my solution, which could be similar to yours sometimes, but it's never the same, so keep that in mind, and I'll talk to you in the next videos. I hope you're having a good time developing this app, and this is my design.txt file, so my thought of how this app should be structured. So that's the title, cinema ticket booking. The description, this will be an app where a user can book a cinema seat if the seat is free and if the user has a balance in their card, bank card. We're talking about enough balance given the price of the ticket, and the app generates a PDF ticket if the purchase is successful. That's what this app should do more or less. And then we have the objects. So a user object, a seat object, and so what other nouns do we have? Balance, but balance is more an attribute of card. So I thought of having a card object type as well, and lastly a ticket object type. The user type, the user class, is going to have a name. So in this case we do have a user class. In other apps that we developed throughout the course, we didn't have a user class because we didn't have to differentiate between different users. But in this app it is important to differentiate between users. So a user will have a name, and that name is going to be printed out in the PDF ticket. And so there will be different users with different names, therefore it makes sense to have a user class. So when we instantiate a user, what do we need to have as a minimum? Well, the user needs to have a name. Therefore, I think name would be an argument, a parameter of the init method. And then a user, what can a user do in this app? Well, they can buy a ticket. Therefore, I thought of having a buy method with a seat and a card parameter. So this method will have these two parameters. Now a seat is going to be this seat object type. So this method gets as argument, when it is called, it gets as argument a seat object instance. So that's an object instance of that and an object instance of card. Because a user needs to have chosen a seat and needs to have a card. So basically, in the code later on, when you do like user equal to user John, and you also instantiate a seed, let's say A1, that seed, and you instantiate a card equal to card with all the arguments needed for a card, such as the type, Visa, 1, 2, 3, 4, 5, 6, 7, 8, so the card number and the CVC and so on. And then you will call the user by method where you pass the seed and the card as arguments. So that one and that. That's the idea. Right, and then we have this seed object type, which is going to have a database parameter, which could be either an instance variable or a class variable. It could make more sense to be a class variable, since the database will not change between different instances of seed. But either way, it would work. Show the path to the database, to the cinema.db database, and then we have the seed ID. So when we instantiate the seed, we're going to have the seed ID and the price of the seed, which actually it's not going to be passed here as argument because we don't know the price. The price is in the database. That could be something like, you have the class seed, and then we would have like def init, and then inside init we could have something like open the connection to the database. So build the connection and then make a query, cursor.execute, and then you get the data, so you get the price from the database. Price would be something like cursor.fetch all. So that would be the price, actually self.price. You get the price from init. That's one way to do it. Another way is to not do that extraction of price from init, but have another method, such as get price. And then in that method, you do the same thing. So you open a connection to the database, and then you fetch all from the cursor, and so you get the price, and this would return the price. So the price would be equal to cursor.fetch all and so on, and you return the price. So either way, it would be fine. I hope that makes it clear. And then I thought of having an availability parameter for seed, which again, it's not an argument, so the seed will not be expecting to get that as an argument, but this would also be extracted from the database. So again, this could also be a method like get availability, instead of calculating availability in it again, as we did for price. So these two are special. So these two can be calculated either through a method or inside init. Alternatively, we can exclude that and have a method such as is available or is free. So is available, or just leave it as is free. Again, this method would return either true or false given that particular seed ID. And then occupy. So occupy would be a method which would get information from this method. So if is free, that means if this is free method returns true, then we change the value in the taken field of the database table from 0 to 1. So we occupy that seed. That's the idea about the seed class. Then we have card. Again, database. This would be the banking.db database with the card table inside. So this would be the path to the database. The type of the card, either Visa or MasterCard, which in my app, in the app that I developed, doesn't have any role actually. So I'm not using that card information for anything, but it's just good to have it there. The number though of the card and the CVC and the holder are important. So the user should pass them in here, and then we check the database table, so the card table. We check the card table if these data are in the table. And we do that check in the validate method. So the validate method also gets a price as argument, so the price of the seed. And actually the user buy method is going to call this method. So in the definition of buy, we are going to call this validated method and pass the price of the seed in there. In buy, we do have access to seed, to the instance of the seed, and seeds is going to have this price argument attribute. Therefore, we can access the price from the buy method. And the validate method will also subtract the price from the user balance in the cart table of the database. That's the idea more or less. Finally, we have ticket ID. ID is going to be generated by Python randomly as a random string, so the user is not expected to pass an ID of the ticket. We are going to generate it. So this could be done in the init method again. So you could have something like ID equal to a random.string or whatever method you can use to generate random strings in Python. You can find that out easily by Googling. So how to generate strings, random strings in Python. The ticket is going to have a user instance, and then from that instance inside ticket, we can extract the name of the user and maybe other information. Well, in this case, only the name, because the user doesn't have much to say, it doesn't have much information besides the name. And then the price, so we want to print out the price in the ticket. Because remember that the ticket looked like this. So it has the name of the user, the ticket ID, the random string, the price, and the seed number. So the price, we have the price here, and the seed, so we can extract the seed number from the seed instance. And then we have this method to PDF, which will save the ticket into a PDF file, into this path, which is just a string. So that's my design anyway. Feel free to modify it as you wish, so be flexible. Don't worry about following my design. And yeah, I'll talk to you in the next videos. Thanks for this and see you.